Hello, this is Mr. Beck Does Your Homework. This is AP Physics Homework 2.1, question number 1. The question states, a glacier advances at 6.3 times 10 to the minus 6th centimeters per second. How far will it move in 7 years? Answer in units of centimeters. Well, the glacier advances at 6.3 times 10 to the minus 6th centimeters per second. I've just seen a number with some units. Centimeters divided by seconds. That is a measure of distance, and that is a measure of time. Anytime I have distance divided by time, well, distance divided by time gives me a speed or a velocity. So I'm going to write that my velocity equals 6.3 times 10 to the minus 6th centimeters per second. It could be velocity, it could be speed. We know that velocity actually includes a direction, but this is good for now. How far will it move? How far will it move? I'm looking for a distance or a displacement. So I'm just going to write distance equals question mark. It's a good placeholder. Next it says in 7 years. Well, 7 years is a measure of time. So my time equals 7 years. Now, do I have a relationship between velocity and displacement and time? Well, yes, I do. I know that my velocity equals my displacement divided by my time. I want to solve for position or displacement here, so I need to get displacement all by itself. The way to do that is to multiply both sides by time. So I wind up with rearranging that equation to get my displacement equals my velocity times time, or my distance equals my speed times my time. If I plugged in this speed and this time, I would wind up messing up my units because this is centimeters per second and this is years. So I have to make the units consistent in order for seconds and years to cancel out. So what I'm going to do is I'm going to convert 7 years into seconds, because then I can plug in centimeters per second, multiply it by time and seconds will cancel out. So I have to do a conversion on 7 years. So I'm going to write times, draw a line. I'm going to put years on the bottom here so that it'll cancel out with the years on the top. What I know about years is that 1 year is the same thing as 365 days. Not exactly, but for this problem, this works very well. Now, that's 365 days is the same as 1 year. So this, in essence, is multiplying by 1. So my quantity hasn't changed. So that would get me to days, but I want to get to seconds. So from days, since days is up top, I'm going to put days in the bottom, and I'm going to go to hours. I know that 1 day has 24 hours. But that's not good enough. I have to get to seconds. So I'm going to put hours in the bottom, and I know that 1 hour is the same thing as 60 minutes. But I'm not quite there yet. One more step. I have 60 minutes. Well, I'm going to put 1 minute on the bottom, and I'm going to put 60 seconds up top. Now, minutes is going to cancel out, hours is going to cancel out, days is going to cancel out, years is going to cancel out. So when I do this multiplication, 7 times 365 times 24 times 60, that will give me some number. And whatever that number is going to be in units of seconds. So now I've converted my time to seconds. Now I finally can combine, and I can say my distance is going to be my speed times my time. Well, my speed is 6.3 times 10 to the minus 6th centimeters per second. And my time that I'm going to multiply by is whatever this is in seconds. So I'm going to plug that number in here. So multiply by this number in seconds. Now, units-wise, seconds is here on the top, seconds is on the bottom, seconds will go away. That will give me some answer in centimeters, and that is the answer to my problem.